Hello and welcome. In this video I will go through ECU Master EMU Black and show how to set up a PC program and how to program the unit. The EMU Black is a class-leading aftermarket engine management system. My name is Frank Winter and I have for the last 15 years worked with Electromotive Tech GT, but now it's time to move to the ECU Master. The project is my old Morgan, which is a turbocharged engine, 1600 cc, with more than 2 bar force power from a turbo, water injection, special pistons and gearbox and everything, producing up to 300 horsepower. And I hope this ECU can do a very good job. Before you start with the PC program, it's a good idea to make all the drawings, the installation drawing with how you want to use IOs, and also if you want to make a special control panel. I have made a control panel which can give you a launch control, traction control indicating a water injection, and fan. My engine is a 4-cylinder, full sequential with cam and crank sensors. It has 504 cc injection, fuel injection nozzles, and it has I have a full setup here with a cam and crank sensor, and can check everything. Also on my 4-channel digital oscilloscope, I can control everything on the ignition and the fuel injection and sensors and everything. After installing the PC program, my laptop is a Lenovo Yoga C930. It's a 13.9 inch screen, and before you can read the left column, you have to set up the software in the proper way, otherwise you will not be able to see everything. What we can do, I can show you. We go in Tools, in Configuration, and you have to change the panel, the parameter panel size to 250 if you should see what is written on the left side. I'm also using a different way of seeing the RPM and the map. I want to have the RPM on the horizontal and the map on the vertical axis, and this you can set up in this one as well. Load on the y-axis, you can check that mark. You also have to check if the firmware in your box, when you're connecting the EMU box, if the firmware is the same as PC software. In this case, you can read it on the right side here. That's the firmware, is 2.113. My box came with 2.066 firmware, and that gives a lot of conflicts in preparing the program in 2.113, where the map was couldn't be transferred when you upgraded to a newer software and firmware. So before you do anything, you have to update to the correct firmware. The firmware, you can say upgrade firmware, and then you have a list of firmware from the oldest one in 2017 2035 to the latest one 2113, and you just open it. It takes very short time to download in the box. And if you're programming the box all the time, you just have to press this one on the left, most left, and when you open a file or making a project name, this is a date and a project name, This is in my box. I open it. Will you write the EMU with this file? Yes, you said. But now it's programmed. On the left side you have sensor setup, engine start, enrichment, fueling, ignition, knock sensor, idle, output, boost, and traction control and sport, where you have a lot of possibilities, launch control. It's a good idea to start up with the ignition, and you can check the triggers. A primary trigger. The primary trigger is the is a cam. Oh, it's a crank trigger. Sorry. And in my case, I'm using a pull down, a variable reluctance sensor, adaptive low threshold, input filter low, and my trigger wheel is two missing T's, 6 T's with 2 missing, and normally should go with the rising edge. It's a 4-cylinder, and here's the number of T's. The first trigger is set to the total of, you have to figure out the TDC, and in this wheel you have 6 degrees per T's, tooth, and how much will it be the most trigger angle? In my case I've set it to 42 degrees, which is 7 tooth, and the first tooth should be set so the 7 plus this number, in this case 4, is the total of numbers of tools from the TDC point to where the sensor is located, in my case at 11. So it's 7 plus 4, which is total 11. So that's correct way of setting it up. The secondary trigger is a cam, and in my case it's 1 tooth or -1 tooth, but it's 1 tooth, and it's on set on the rising edge. I have this up here. You can see this is 1 tooth. Here you can see the missing tooth on this. It's made by myself. The next thing is ignition coil. I'm using the electromotive coil, which is a dual coil, wasted spark with no amplifier, and ignition output 1, 2, 3, 4, and it simply changed between the one coil, output 1, second coil, output 2, then first coil again, and second coil, and the firing order in my case is 1, 2, 4, 3. The next thing to do is to set up the ignition table 1, and I'm working in a range where I have the RPM on the x-axis from 800 to 6,773. You can set the axis by right click on the mouse, x-axis and y-axis wizard, and in my case I go from 20 kPa to 300 kPa, and you have to set up the ignition table totally, and I'm using more or less the same figures as I was using in the Tech G. Next thing is fueling general, and fueling general is a 1600 cc engine. Fueling type is speed density. I'm using a map sensor. Enabled barometric correction. I'm using the built-in barometer as barometer correction, and I have an external map sensor, and the injector size is 504 cc. Next thing is the fuel table here, and the first V table 1 is here, and this one using volumetric efficiency. I was using the a different way in electromotive, but I have converted this to volumetric efficiency. So I've been setting up all these different figures. Next thing is to set up a lambda target table. In this case it's 8 by 10. Actually it in the previous version of the firmware it was 16 by 20, so it's getting smaller, and it couldn't convert from the 16 by 20 to the 8 by 10, so I have to start by hand to enter all the figures. Or I don't go into detail how you highlight and enter all the numbers. Then we'll go to the injectors. Injector phase, and phase 1 ignition, phase event 1, and phase 2 injector 2 is in ignition event 2, 3 is for 3. That's how the ignition fires. I have not tested it yet, but I hope it's okay. The first menu is a sensor setup, and you can have analog inputs, momentary switches, smoke switches, oxygen sensor. Let's take the oxygen sensor. I'm using an external controller, and I've set up the table for AFR 0 volt. It's 10 AFR, and at 5 volt it's 20 AFR. I'm using external controller input number 1 at B Black 33. TPS, you set the numbers there. Most sensors has dedicated input, but you can set what type it is here. It's a Bosch 2.2 kilo ohm, but you can also change the table and set up all the details on the calibration. So if we take the calibration here, IAT calibration, you can put new figures in at 20 degrees, 2.67 volts, but you can change everything. I'm using VSS, that's the vehicle speed sensor, and I'm using a Hall. It's a rear wheel drive, and I'm using a 50T's ABS sensor on that. So you have to put in a number to get the correct reading of the speed. Divided by 16 and speed radio 0.523, then it's calibrated to the vehicle speed. In the sport menu you have the launch control parameters. I'm using active analog input to adjust the sensitivity, speed, and B37, and no, that's the input, and the blend input is analog input 2B. I won't go through all the menus and settings, but I want to start the simulation of the motor. Here we start. Now it's the cam and the crank and the setup. This is my launch control. I'm not using that one right now. But here we have the tuning table. First you have I can adjust the lambda on one of this potmeter here. Set to the target, that's 2 bars. I can set the pressure, and we can see the RPM, the map, the TPS, the volumetric efficiency, the ignition, the injector pull width, the CLT, the AFR, and enrichment. We can just take a look on this one and see the ignition is 24 degrees before top of compression. The dwell time for the point is 3.1 milliseconds. The synchronization is the cam is 89 degrees juiced before top of compression. Cam trigger is okay, and synchronization, we can just expand it, see what it says. No, It's synchronized, no errors. Here we can see this one is a water injection, and it's depending on how much pressure. It starts at 180 kPa, and the blower is going on. That's the blower. You can just adjust the temperature a little bit down. Now it's stopped.